Hi everyone, this is our group's final project, and our title is Parameter Estimation of the Arterial Spin Labeling Kinetic Model using Machine Learning Method. I'm Ziyi, and my teammate is Yining, and I will introduce the introduction and method of our project, and Yining will introduce the results and conclusion for us. Next slide. Yeah. So machine learning has been widely used for image classification, object recognition to use compute algorithms to model human perception decision processes. Recently, machine learning algorithms achieved great progress for tasks like modeling fluid dynamics, predicting structure of proteins, and forecast prediction to scientific problem using data-driven method. Our target is to using machine learning method to do parameter regression for arterial spin labeling kinetic function, which is the nonlinear function. So arterial spin labeling is a non-invasive MRI technique, and the blood water entering the brain is labeled by magnetic inversion, and after a post-labeling delay, an image is acquired. The PLD gives the labeled blood time to travel from the labeling region to the tissue bed, this time being referred as the arterial transit time, ATT parameter. This labeled image is subtracted from a control image where the blood is not labeled, then resulting in an image with a signal intensity proportional to the cerebral blood flow CBF parameter. Then we can use the inversion model to quantify CBF. Next slide. In our project, we will first simulate the kinetic model function and sample output function value with sample points of each set of parameters, CBF and ATT parameters. So this is the ASL kinetic model here, and the delta M is the ASL signal difference, which is the signal we acquired, and the T is the time from start of labeling. Tau is labeling duration, and F is the CBF we want to quantify, and the ATT is the delta T here. We will deliver two experiments. The experiment A is to simulate CBF values from uniform distribution with range from 0 to 100, and ATT values from Gaussian distribution with mean of 1 and standard deviation of 1. And in this experiment, the distribution of our training data set and the testing data set is are the same. Then we will deliver the experiment B, which is to use all of distributed data in our ATT parameters testing set. Here, the ATT values is from the Gaussian distribution with the mean of 1.2 and the standard deviation of 0.25. Next slide. Yeah. So we compared two neural networks for parameter estimation. There are their neural network architectures. For regression neural network, which we treat as a regression network, which is a 4 layers network, and for regression as classification neural network, which we treat as a classifier, the neural network is a 3-layer network, and the output here is 100 plus 40 channels because we treat the ATT values as a discretized label for classification. The error function here is a normalized error. Yeah.
Here shows the results estimation from the trained neural network comparison between the regression neural network and the classification as regression neural network. When there's no ATT distribution shift for signal dataset generation, the regression as classification neural network achieves better performance in ATT parameter estimation, and the regression neural network achieves better performance in CBF parameter estimation. Less variance across different ATT and CBF values is observed for regression as classification neural network than the purely regression neural network. For the error functions evaluation for CBF and ATT estimation under the training data set whose distribution are a little bit different, the regression as classification neural network achieves less error than the regression neural network. This demonstrates that the classification neural network is easier to achieve higher generalizability than the regression neural network, and might be more suitable for practice when the parameter distribution is unknown for the training and the test dataset. Our conclusion is that regression as a classification neural network outperforms regression neural network for parameter estimation of ATT and CBF when there's a distribution shift between training and test dataset. Regression neural network outperforms regression and classification for CBF estimation training. One possible reason for superior performance of regression as classification neural network is that cross entropy loss could decrease the implicit bias of neural network during optimization. Here is our references. Thank you.